Welcome back, and now after we have dealt with this formulae, then now we can finally, before we do calculations, let's talk about the root mean square. RMS, which means your root mean square, in this case. So if it's VRMS, I mean that is root mean square voltage, and then if it's IRMS, is root mean square current. Let's define the two, because if you draw a graph, you will find that now in a normal graph, if it's a voltage time graph, then this is the graph. The highest value there is Vmax, and the lowest value here is still Vmax. Then where is VRMS? Normally we are using the value here just below the Imax or Vmax. This will be my VRMS. That with the VRMS I can still calculate the maximum voltage, or with the maximum voltage I can still calculate the VRMS. Therefore, by definition, root mean square voltage is an AC voltage, or potential difference, AC voltage that dissipates the same amount of energy as DC voltage. And then whereas the IRMS, root mean square current, and this one will be now an alternating current, that dissipates, the same amount of energy, as direct current. That's the two definitions. Now let's talk about an activity here where now we can put these skills to test, what we have learned now. Here is the question. In this case, let's say you are given this type of a question. Hope you can see we have got the magnets. We have got a coil. They show us the direction of the magnet. These are the slip rings which are indicated here together with their brushes. Now we have got this type of a coil, and in a magnetic field where the left hand side is north, the right hand side is south. Then we've got A, B, C, and D. Now they say this diagram represents a simplified electrical machine. The coil, very important, they say now the coil A, B, C, D makes 20 cycles per second. 20 cycles per second. What does this mean? This is frequency, and that the frequency of the machine is 20 hertz. Fine. Then they say the direction of the current in the coil is from A to B as indicated here. Now answer the following questions. The first one, what type of electrical machine is represented by the diagram above? So the machine in this case, where now we have the energized coil here, the current is given. Therefore, this type of a machine now becomes your, in this case, your generator. Therefore, this is a generator. That's number one. It's a generator. Fine. Number two. Now they are telling us to say, name the principle which the machine operates. We know the principle of generators. It's a electromagnetic induction. The third one says now, in which direction is the coil rotating? Choose from clockwise or anti-clockwise. Then now we know the generators follow, motors oppose. Therefore, if the current is anti-clockwise, you can see the current will be moving in an anti-clockwise way. Is a generator, the rotation also will follow. Therefore, the answer will be anti-clockwise. Now, the next question, in this case, they're saying to us quickly, how long does it take the coil ABCD to complete one rotation? What is the period of this one? We know the period equals to 1 over frequency, which is 1 over 20, which will be 0.05 seconds. That is the answer. The next one says, state one way in which this machine can produce lower output voltage without changing the construction. How can you now produce low EMF without changing the construction? We know that we can decrease, we've got options, decrease the speed of rotation, in this case. That's the one that you can do it without changing construction. An electrical device, in this case this is a new one, electrical device, which is just a subsequent question from this. Electrical device, it's rated 220 volts and 1850 watts. Let's pause and solve this one when we come back.